Today, we will be covering trigonometry. This is where we will deal with the relationships between the sides and the angles in a triangle. So, we'll start off by drawing our triangle. And SOHCAHTOA only works with right angle triangles. So we label our angle theta. And so, opposite theta, we have, you guessed it, our opposite side. Adjacent to theta, we have our adjacent side. And we have our hypotenuse, which is opposite our right angle. And so in trigonometry, you'll come across this term called SOHCAHTOA, and it can be split into three different distinctions. SOH, where sine theta, theta being the angle, is equal to opposite over hypotenuse. CA, which is cos theta, is equal to adjacent over hypotenuse. And TOA, where tan theta is equal to opposite over adjacent. And this forms SOHCAHTOA. Now, we will find the length of side x. So what we're going to start off with is labeling the sides of a triangle. So opposite our angle, we have side x, which we take as our opposite side, and we have the hypotenuse. And so, since we have the opposite and the hypotenuse, we use SOH, so we use sine. So sine of theta is equal to opposite over hypotenuse, as we've seen before. So sine of 55, which is the angle size of theta, and then our opposite, which is x, and our hypotenuse, which is 75. And so we rearrange to get 75 times sine 55 is equal to x, and we get x as 61.436403332. So x is equal to 61.44 to 2 decimal places. This is in centimeters, as our hypotenuse was 75 centimeters. Now, moving on to our next question. We'll once again label our sides. So we have our hypotenuse opposite our right angle, and we have the side that is adjacent to the angle given. So we use CA here, where cos theta is equal to adjacent over hypotenuse. Now we substitute our value, so cos of 48 is equal to 28 over x, and we rearrange to get x is equal to 28 over cos 48. This gives us x is equal to 41.84534. So x is equal to 41.85 centimeters to 2 decimal places. Now for our last question involving sides, we're once again going to label the sides of our triangle. So we have the opposite side to our angle, which is given as x, and the adjacent side to our angle, which is 18 centimeters. And so we use TOA because we have our opposite and our adjacent sides. Tan theta is equal to opposite over adjacent, and we substitute our values. So tan 22 is equal to x over 18. We rearrange 18 to the other side, and we get 18 times tan 22 is equal to x. X is equal to 7.272472065. So x is equal to 7.27 centimeters to 2 decimal places. So now we will encounter a question where we have to find the angle. So we label our sides, opposite and hypotenuse are given. So we use SOH. So sine theta is equal to opposite over hypotenuse. And we substitute our values. So sine of x is equal to 42 over 48. And now to find the angle, we take sine inverse of 42 to 48. This will usually be given in your calculator, and you can use that alongside your sine value when calculating questions in trigonometry. So in this case, we get x is equal to 61.0449753. So x is equal to 61.042 decimal places. Now here's another question where we take a look at the angle. And so, as always, we start by labeling our side. So opposite our right angle, we have our hypotenuse, and we have our adjacent side next to our angle. So since we know that, we can use cos theta is equal to adjacent over hypotenuse, and we substitute our values. So cos of x is equal to 7 over 20. So x is equal to cos inverse of 7 over 20. You can probably find this function in a similar way that you found your sine inverse function. This gives us our x value as 69.51268489. So x is equal to 69.51 degrees to 2 decimal places. So as always, we're going to start off by labeling our sides. So opposite our given angle is our opposite side, and next to our given angle is our adjacent side. And since we have our opposite and adjacent, we use TOA. Tan theta is equal to opposite over adjacent, and we substitute our values. So tan of x is equal to 3 over 6. X is equal to tan inverse of 3 over 6. This function is found in a similar way to your sine inverse and your cos inverse functions on your calculator. So you end up with x equal to 26.5650518. So x is equal to 26.6 degrees to 1 decimal place. So you may be wondering what sine, cos, and tan are. Well, they're actually functions. So here we have a graph of sine theta. And so every x value, so every point on your x-axis is a value that theta can hold. So it's every value of theta. And the y values are every output for your corresponding value of theta. And notice how it remains between 1 and -1. This is important to remember. In a similar way, here we have our cos theta graph, where, just as the sine graph, your x values are the values that theta can hold, and your y values are the outputs of your cos function, and just like a sine graph, it remains between 1 and -1. And now we have our tan graph. And so this is different to your sine and cos graphs only in its shape. So its x values remain as the values that theta can hold, and your y values are the values that get output. However, you can see that the curve does asymptote at certain points. This shows that there is an indefinite answer to the tan function. As always, thank you for watching, and make sure you subscribe to ensure you do not miss any new content.